Hello, everyone. So you already saw one presentation from Marcello. Hanno presented you the concept of shadow tree. And now someone also asked about the real-world example. So here it is. Do you even need to re-render? Hi, my name is Jacek Pudysz. I'm a CTO at CodeMask. It's a company based in Poland. And here are my handles if you want to find me on GitHub or on X. You may also know me as the author of Unistyles. And today, I would like to introduce you to the concept of no re-renders, at least on the C++ side. So, before we jump into the deep water, let's start with the simple stuff. Styling in React Native is easy. You have one API exposed to you from React Native, which is a stylesheet API. This is like a function where you can put your plain objects. Yeah, everyone knows that. But we have few issues here. So it's only processed once, unless you move it to the component or you will wrap it in the hook. But by default, it only processes once. Also, you can see that background color and color is fixed. There is no way to change it during the runtime. For example, when user will switch color scheme. Unless you write your own hook and you will re-render it every time. So that's another approach. Yeah, so we have no dynamic values, but not only colors or sizes. There is no place for functions. You cannot call this container style from the component. It's fixed. Again, what about dark mode support? Like this is the obvious step when you want to build your native application. What about breakpoints? What if you want to target like tablets? They have bigger screens. What about variants? What about multiple teams? What if you have like 10 teams and you sell some teams in your app? What about functions, dynamic styling, and so on? I'm pretty sure that everyone from you faced this issue before. Well, and here we are. That was me. Almost 3 years ago, one of our clients reached to us to build native application. But it was specific native application because we had to target Android, iOS, tablets, and web. That's not all. They also prepared hundreds of wireframes. They had the own team of graphic designers. So I was sad. I was looking as a CTO for the solution, but I couldn't find one. So in January 2023, I started to build in the code base of my client Unistyles. So it's called Unistyles 3.0. But it was so tightly coupled with the code base, I couldn't extract it and share with the community. After we finished the project and released it, I did it, and I released version 1.0. It was only about the JavaScript. There was no C++ code, nothing. It was based on the hooks, like I mentioned on the second slide. Then, 2 months later, I thought a little bit, how can I improve? So I decided to add additional functionalities like exposing some native values, native sizes from the C++, like your screen width, dimensions, so it's always dynamic, it's always up to date. So I released 2.0 only after 2 months. Then I had to take a break because it was a lot of work. And last July, I started to prototype 3.0. This is the biggest update since version 0.1. And today, we are on beta 8. So we are not ready, we are not production ready, but it will change soon. So now, I introduce you to the concept why I did it. So let's talk about Unistyles. Again, I will bring back the default example. So this is like the regular style sheet from React Native. And in order to convert it to Unistyles style sheet, you just need to change the import. That's all. You are now ready to pass your styles to the components. But it's not that easy, yeah? Because firstly, you need to configure your theme, but it's like one more function, and then you can change your objects to function. And here you will get always up-to-date theme selected by your user. And right now, with the theme, we can update the values, so they are no longer static. So this is a drop-in replacement of the style sheet. You can use objects like in the regular style sheet, but you can convert them to functions. Also, you have dynamic themes. There is no limit of number of themes. Also, there is no limit on the structure of your theme. You can put there whatever you want. And it has some superpowers. You can use variants, compound variants, theming, like dynamic values, and so on. Also, if you accept the second argument, this is your native runtime. So you can access multiple metadata like screen dimensions, some kind of accessibility values, color scheme, orientation of your font. So everything you need to use for your styles. Now, today, I won't gonna talk about the Unistyles features because we have a lot of them. One of them is like custom CSS parser, so we put everything into CSS variables. You can use pseudo classes in your style sheets. So there are a lot of features, and I will only focus on the one topic, which is shadow tree updates. Before we jump into the shadow tree, I need to present you or describe you how Unistyles works. So again, we have a simple style sheet. I just converted the font size to the breakpoint. So for the smaller, extra small screens, you will get 20, and for the medium screens, you will get 16 pixels. Of course, it's configurable, so you can put as many breakpoints as you want. I also attached runtime insets. So you can also pull your up-to-date insets from the runtime, and they are attached to padding top. So this is like the same example with two changes. First of all, we need to detect dependencies. And why we need to do that? Because we will pass this function to the C++. So we will lose all the information about your theme. So we have a style sheet, like here, and it has two dependencies. You accepted two arguments, so it depends on the theme and runtime. Now we also have two styles. We have container and text. Container depends on insets and theme, and text depends on breakpoints and theme. So this is our dependency graph of your style sheet. If we have our dependencies, we can now register our style sheet, and whatever you can see from this point happens on the C++. So I expose hybrid style sheet. This is like the React Native Nitro hybrid. And whatever you have like in this pink parenthesis, it will be passed directly to the C++. So whatever you can see here will be executed on the C++ side. And you used like theme and runtime. So we have like a dedicated type on the C++ side for such style sheet. And we now can or should register the style sheet with style sheet register. This is like a Unistyles feature. So it's not about the React Native. This is like built on top of the React Native Unistyles core. And here is our style sheet. Let's call it style sheet 1. But in the future, like you may have multiple style sheets. Each app has multiple style sheets. So we will actually recreate your structure of all your style sheets from the JavaScript on the C++ side. So from now on, I can reference your style sheets from the C++. Now we need to register Unistyles. But what is Unistyles? Like, is the library? Well, Unistyles is a special term in Unistyles 3.0. So again, we have our registry where I hold all your style sheets, and we have our single style sheet that contains two styles, container and text. Now, before I do anything, I need to parse your style sheet, because you may have a lot of breakpoints, media queries, like a weird syntax that is not available on the React Native style sheet. And actually, our parser on the C++ side has exactly 1,000 lines, like 1,000 lines. I checked it yesterday. So I move your container and text styles to the parser, and it will produce Unistyles. Unistyles are a C++ pointers to the parsed styles with the metadata. And we keep some kind of metadata. I will show you the example. So, for example, we have one Unistyle, which is a type of object or dynamic function. It depends on you. For example, we have a style key container or text, and we have dependencies. So they are pulled from the Babel from the first step. Also, I keep like the raw value, which is in this case for container JSI object. And there is a special case because, as you remember, I mentioned that you can use functions. So you can use something called dynamic functions. So let's say your text style is now a function. You can call it from your component, and it may have multiple arguments. In this case, I will pass font size from the component to the style sheet. And this time, our C++ Unistyle will have type of dynamic function, style key text. It will have only single dependency because it depends on your team. And I will also keep your raw value as JSI function this time because this is a function, but that's not all. I will also, during the runtime, memo your last arguments. Why? Because in the future, I will call this function from the C++, and I need to know your arguments. And I cannot use JSI to hold the values because we need another structure. This is like an open source library from Meta. It's called fully dynamic. I can hold any JavaScript value there. Now, before the last step, where I will explain how Unistyles work, we need to also understand dependencies. So dependencies is not only about the Babel and saving them on the style sheet on the C++ side. So this is the style sheet registry, and we have multiple style sheets. And our style sheet is the first style sheet. And each style sheet may contain one or multiple Unistyles, C++ pointers. So in our example, we had two styles, container and text, and container depends on insets and theme, and text depends on theme and breakpoints. But actually, Unistyles can reference up to 15 dependencies. For example, keyboard height, navigation bar size, pixel ratio, or some kind of accessibility values like content size category. So whenever you will access these values in your style sheets, I will save it, and this metadata will be attached as numbers to the style sheet C++ representation and Unistyles representation. So we have 9 because insets are 9, 0, and 3. Now the final part. Why would I save your style sheets and bind them and create different representation of styles? Because it's required for selective updates. Like that's the best selling feature of Unistyles 3.0. So we have a phone that can emit some kind of C++ event. This event may be produced by user, for example, when clicking on the button to switch the theme, or by the device, like changing device orientation. And whenever you send some kind of event, I will look for any style sheet in the C++ registry that contains one or multiple Unistyles. You should read it by vertically. So for example, style sheet 1 has 2 Unistyles. And well, let's see what's happened. So let's say your user will rotate your phone, and we will emit C++ event. And I will know that, for example, style sheet 2 and 4 depends on theme or orientation. And I will only know that I should grab them and look for Unistyles that depends on this change so that I can build the new shadow tree and update it without the re-render. And again, here is another example. So for example, one of your users switch your color scheme to dark. And then we can select another style sheets and find dependent styles. OK, so let's talk about shadow tree. Like this is the real example. So let's check what we've done. So we have style sheet representation on the C++ side, and each style sheet contains multiple styles called Unistyles. We also know each Unistyle and style sheet dependency, so we can perform selective updates. So we can take dependent styles based on the event. Now, in order to finish our job, we need to do two more things. We need to know how to link styles to views, because there is no information in the style sheet that, for example, one of your view uses a Unistyle. Also, we don't know yet how to perform shadow tree commit. So let's learn how to do it. So here is our Unistyle. Let's say it's our container. And this is exposed to you back from stylesheet.create as JSI object. And this JSI object contains like regular style values like flex1, background color. It's parsed. It has all the React Native compatible styles. But there is one hidden thing inside this object. There is a JSI native state. So if we bring back this Unistyle from the JavaScript to the C++, I can deduct the key or ID of this Unistyle. I can convert it back to my C++ shared pointer Unistyle. So that's why we need this JSI native state. And I guess we need to do the same with the shadow nodes. But where can we find shadow nodes? Our shadow tree, you can imagine this tree like that. I actually generated it with the ChatGPT, and it's not true because you need to invert it. So the root is at the top, but let's pretend this is like the root of our tree. And our tree represent all the shadow nodes. That's what also Hannes showed you in the previous talk. But again, what are shadow nodes? Okay, we have a tree and so on. The truth is, every React Native component or custom component, if you build one, is a shadow node. So we need to figure out how to get shadow node, for example, from React Native view. How to do that? So we need to go very deep. So handle is actually a reference to your component. And each component, maybe not each, but many of them have different paths. So that's why I need to perform a lot of checks if this is a scroll view or text. And somewhere there, deep in the node, there is a hidden JSI native state from React Native. And this function is called find shadow node from handle. Now, okay, we have our ref, we have our Unistyles, our parsed styles. So we need to call another hybrid and pass the shadow node, like this is the returned value from find shadow node for handle function, and one or multiple Unistyles. Now on the C++ side, React Native expose for us one helper. It's called shadow node from value. You can import it, and it will look for the native state inside the node that we found in the ref, and we can cast it or get from it shadow node. And actually, I do the same with the Unistyles. So as you remember, I also attach JSI native state. So this is my custom function, and I can grab multiple. So std vector is like an array on the C++ side. So I can get all the Unistyles, and I can access all the pointers to my styles. How to get shadow tree? So in Fabric, you can do that in 100% from the C++ side, unless you want to use hooks, shadow tree hooks. So this is like one liner. You just need to have access to runtime. And the return value from get shadow tree registry will be our reference to shadow tree registry. Now, if we have refs, if we have Unistyles, if we have shadow tree, then we can do two things. We can get shadow tree based on the surface ID, Or this is like the second method where you can enumerate all the surfaces. So this is like an example how to handle multiple surfaces on your React Native app. And if you pass, like this is weird syntax, but this is a C++ function where you can put dependencies and so on. But you will get from the React Native 2 arguments. The first one is shadow tree, and the second one is a reference to the boolean, which you can later mutate and stop iterating over all the surfaces. And again, it was mentioned by Hanno in the previous presentation, but I would like to focus on the one function. It's called transaction. It's not there yet, but it's here. So transaction is another C++ function that you need to build and pass to shadow tree commit, where you will get old shadow tree node. And now you can mutate it. You need to mutate it because it can be accessed from multiple threads. So that's why there is no like immutable API or like a helper function to find node and mutate it. You need to traverse entire tree and mutate it. And Unistyles exposes shadow tree manager. This is like a helper from Unistyles to clone shadow tree, and it accepts 3 arguments. So the first one is old root shadow node. The second argument is a pairs of your refs of your shadow nodes and Unistyles attached to them. And we need to also pass affected nodes, so we will know which nodes are affected. Now, we don't have time today to dive deep into the shadow tree commits, commit hooks. So we have a mount hook, we have platform tweaks like for Android. You need to mutate shadow tree differently and how to traverse the shadow tree. But if you are interested in such topics, you can browse Unistyles repository. Now, we did everything. We took shadow nodes from refs. We recreated your style sheets on the C++ side. We know which styles depends on which events. We can perform selective updates. And the result is here. So this is like a quick demo created with React Native Scan. So it will highlight components that re-rendered. And on the top, we have 2 buttons. The left one is change theme. So this is like user events that will be sent to C++, and Unistyles will perform selective updates. And the second one is to re-render the page. So we will see actually how it differs. So if we will re-render, everything is highlighted. But if we change the theme with Unistyles, there are no re-renders. Actually, if your user will switch the theme, I will find dependencies of every style sheet that depends on the theme, your Unistyles, your parse styles. I will compute selective updates. I will know exactly which styles should be updated, and I will convert it to the shadow tree updates. One more thing. I'm thrilled to announce that today, after the talk, I'm going to release the first release candidate of Unistyles 3.0. If you want to learn more about shadow tree, Unistyles, please get in touch with me, and I'm ready for QA session.
Thank you very much. It's a massive round of applause. Cool. So for the audience, get submitting with your questions on the QR code. Thank you for your talk.
Thank you.
A quick few things. I'm going to start high level because I know a bit about Unistyles, and you didn't really touch on web today.
Yes.
I know one of the things that was on your roadmap was eventually having no JS-based styling so that it's running on CSS and it's compiled to CSS ahead of time. Is that also part of 3.0?
It's already done, yeah.
Okay, cool.
So actually, it's possible to remove React Native Web dependency at the moment.
Oh, cool.
But the only part that we need React Native Web is to convert your views to divs or to text and so on. But we are working on that, so it's possible to generate like CSS media queries without React Native Web.
Cool. Very, very, very cool. That's awesome. I want to dig into like this approach, and I've seen it with a few libraries where you're kind of escaping the React paradigm in some capacity to
Yes.
achieve the performance benefits, right? So FlashList has a very similar approach as a library fundamentally. It means that there's differences in behavior compared to what like the React programming model talks about. Do you see any risks in that as a library maintainer? I know that the folks at Shopify decided to take on those risks regardless, but I'm curious as to like if you thought about that as the way that you're designing this, obviously because the optimizations aren't in React anymore, they're C++ layer on the shadow nodes.
But it's the same with the web. You use CSS.
Mm-hmm.
So why don't you re-render your React web components if you have CSS? So I think React Native deserves something like that, like to skip re-rendering your business logic. You can update styles from the background.
That makes sense. Okay, that's very fair, and I can see that from a design philosophy perspective.
Yeah.
Very cool. Okay, is Unistyles still incompatible with Expo Go? Is there any workarounds?
Yeah, this is my favorite question.
Sorry.
So this is a question for Expo. Why they don't like inject or precompile Expo Go with Unistyles? Because I cannot do that. If they do that, it will be supported.
Well, there's folks from the Expo team here, or at least Caddy here.
Yes.
So maybe you guys should have a chat. But I think maybe just going at Expo Go for a second, I feel like Expo Go is being encouraged more and more for you to use less.
Yes.
So I think you should be on dev builds generally. Someone from Expo is going to yell at me for saying that. But yeah, like most people are on development builds these days, so it's not that big of a problem as it was when everyone was using Expo Go back in the day. Is 3.0 compatible with the old architecture?
No, and it won't be because we are too deep into the fabric. So it's possible to do that, but why? If like new architecture is like the new way of building up, we were waiting for it a few years, so we should stick to it.
We should use it as much as we can.
Yes.
And you'll see in the panel later on that's going to be a topic of conversation. Is how long should you support the old architecture for? Is it possible to animate the value of Unistyle? Example: switch the theme without a blink, but ease in and out.
No, you have for that reanimated. Like reanimated is compatible with the Unistyles. So what would I like build another animation library if you had great one like the number one there? So you can use reanimated, and that's all.
Cool. One person is just congratulating you and saying it's a very impressive demo. So nice work to you and your team. We'll do one more question. Just because we want to stick to time as much as possible. What was the hardest obstacle that you and your team found while working on version 3.0 of Unistyles?
I think it was understanding how it works. So the presentation like from Hanno, like it's the best value from the community because we can understand how it works underneath. Because there is no documentation, you can actually read header files from the C++, or you need to read React Native code. I think, it's possible to understand it, but it would be great to share the knowledge. So that's why I did it today, and so that was the toughest part of the Unistyles.
Well, some of the new ChatGPT models like O3 are quite good at understanding code when there's no documentation for it. So hopefully that process becomes smoother and smoother for everyone. Jacek, thank you so much for taking your time
and
doing this talk. Appreciate it.